So some of the things I'm not going to talk about, and I even think that someone later on this day going to talk about Firebase. So don't worry, I'm not going to duplicate these talks. When I say serverless in this session, I'm going to concentrate on functions as a service, although there are many other kinds, many interesting kinds. And when people ask me if serverless is here to stay, I definitely think so. You know, there's always a discussion going on between serverless and microservices, and there's a big question if serverless is needed now with Kubernetes, and the fact that you can deploy microservices very easily and enjoy everything that Kubernetes gives you. But I think serverless has some advantages, and even the serverless first approach is getting more and more common, even in AT&T, which is a huge corporate. And you can check out Joe Amison's name. He's built 3 successful startups, fully serverless, from database to code to everything else, not a single server he managed, and he's doing great. So check him out. He's got some nice success stories published. And I think that for a reason this conference is API and serverless, they go very well together. And also I've noticed in the past 2 to 3 years, a lot of new companies that are concentrating in giving services to serverless, either monitoring, reporting, security, orchestration, development tools, whatever you want. All the environment is there, and they keep on growing. That's why I believe it's here to stay, and I'm acting upon this belief in AT&T. So a little bit about why AT&T is even related to serverless. The stuff that I can tell you is AT&T is moving applications to the cloud, to Azure in this case. And they have more than 5,000 applications. It's a huge company, many applications. We do a lot of modernization, some of them to serverless, and we divide this effort into 3 paths. The path of what we call optimization, which is basically lift and shift. You can understand that this is relevant only to relatively modern applications, which are already cloud ready, cloud native, maybe even running in containers. So we just take them and put them in Azure as is. The other side is transformation, meaning rewriting the application. This is relevant to very old applications, sometimes mainframe applications, sometimes COBOL, Natural, even C. We just rewrite them, try to understand the functionality if it's still relevant, design them from scratch, and move them to the cloud. This is where we use serverless where it fits. And modernization is the part in the middle. These are like, I don't know, 10 to 20 years old applications, which we take. We don't want to change the code there, but we do some adaptation. We use cloud services like the serverless databases. We use queues in the cloud, event hubs. Anything we can use as PaaS, we'll do that without changing the code. By the way, in some applications here are so old that no one knows where is the code. We just get the binaries, so we can't do anything with that. Or even the functionality. No one can describe the functionality. So it's a very interesting process. Don't think that any other company has done it or doing it in such a scale. The budget is enormous. And the last bullet here is is an opportunity. I don't know if you guys are from any startups, but we are always happy to do design partnership with startups, by startups. If you're into cloud security, cloud reporting, the hot topic now is cloud cost, because the cost is getting higher, as I will soon show you. So FinOps is a big topic right now. So if you have anything you think you can offer to AT&T, please share it with me later or drop me a line whenever you're ready. And going to the public cloud for serverless functions is the obvious choice, right? It's the easiest. Everything is already there. You don't have to install anything. Just upload your code. It has some limitations, obviously, for memory and time, but the normal offer, not all of the offers, but the normal offer is pay by consumption. The more execution you do, the more you pay. There is some penalty for memory, but mainly it's based on number of execution, which is great, but not for everyone. And you can trigger these functions in a lot of ways. So this is where we headed at the beginning. And of course, if you're going serverless, why not use everything as serverless? So this is a sample. Actually, it's from AWS, but because the icons are more familiar, but it's the same in Azure. Same services appear here and there. They're competing each other, so it's easy to duplicate. So building applications in serverless doesn't just mean, for us at least, taking all the code and transferring it into functions. It's a different state of mind, right? If you can do everything serverless, you get the scalability, you get all the benefits, which is great. In this simple example, you can have a S3 bucket, and whenever a file appears there, Lambda function can be triggered and then send it to a queue or send it to a database. Other Lambda function can read it. You can expose via API gateway, and currently AWS will let you expose Lambda directly as URLs. So everything is fine, at least in theory, right? So on the drawing board, everything is easy and simple. In real life, it isn't, right? I think we all heard some variation of this saying that when you're a small company, you better start in the cloud. But when you're a big company or have lots of presence in the cloud, you better come back in because the cost is going to be too large. And we all know Dropbox story. And if you don't, I'll just mention it in a few sentences. They started in AWS, got really large, and their bills got extremely large as well. So they did a reverse migration, what's called repatriation. And now they're running their own data center. We're starting to see that in AT&T as well, right? I can't give numbers, but I can say that every month, quite a few millions are being paid for Azure. This is one reason, this table right here, for security reasons. The CSO does not let us run the basic consumption-based functions in Azure. He wants everything to be running in the same VPN per application. And you pay for that. There's a cost attached because the premium version is basically based on virtual machines. You don't really pay for consumptions. I hope you can see the numbers here. And actually, it's a bit tricky to do the comparison because the way they calculate it is different. This is per consumption, per execution, and gigabytes per second. And here you pay as if it was a virtual machine. So we pay a lot for function, which discourages us from using it more. So we looked in other directions as well. What about running serverless in-house, right? No one's forcing you to run it in the cloud. There are a lot of serverless frameworks out there, which I soon show you, and it has many advantages. I mean, even if you don't pay much in the cloud, you should consider it at least, right? Easier and faster to develop locally, right? And if you do want to go to the cloud afterwards, it's cloud agnostic. You don't use specific APIs of a specific cloud provider. You have a choice. You can run it in-house. On your servers, you can use some private cloud like VMware or other open source private clouds. You can run in a hybrid model. Start locally, and if the capacity grows too large, you can switch to a public cloud using Kubernetes. It's very easy to do. And you can save money and develop faster with it. Even prod might be cheaper to run locally. It depends, of course, on the type of your application and your workloads and how many times your functions are being called, but it might be. Sometimes you don't have a choice. These are big markets, right? We might think of quick and small startups running in the cloud or a single developer building something in the garage using the cloud, which is great, but there are many huge customers or huge organizations that cannot go to the cloud because the data is classified. If talking about government or financial information in banks or homeland security or others of the sort that cannot go there. This is a huge market. They can also benefit from serverless by using some serverless framework, right? Because the benefits of serverless are not just the cost. It enables you to develop faster. You just develop a function, deploy it in a click, and it's there in production. Much faster than running a monolith or a microservice application. And I think that this is like the best we can do. It's just the code. So we thought about running serverless locally, and we checked some serverless frameworks. And there are many options, but they all have these things in common. I will show you an example or a few examples soon, but check this out. They all run these functions in Docker containers, right? It makes sense. Easy to store, agnostic to the programming language, write in whatever language you want, wrap it in a Docker container, easy to orchestrate later, easy to store, easy to manage versions. And then there's some gateway or load balancer or whatever you call it, depends on the framework, that exposes itself to users. The users can be browsers or other applications. And this gateway routes the calls to some server that will actually run the functions, right? And this server can be part of a Kubernetes cluster or a simple server that you use. Usually you kill the function after it's finished. You let it live for a little while to avoid paying a penalty until it starts up again. But usually keep it for a few seconds and then you kill it if no one calls it again. Usually these frameworks provide easy monitoring, reporting, etc. And you can access them via management UI or a CLI or some REST API. They are similar in this way. For example, OpenFaaS, a common serverless framework you can run at home or at the office. As you can see, there's a gateway that accepts the call, exposes a REST API for the UI or the CLI, and passes the calls to Kubernetes cluster. And the functions, again, are images, Docker images, that are being deployed to the cluster when needed, with some reporting and monitoring capabilities with this framework, Prometheus and Alert Manager. Another one used to be IBM, but now it's open source, has the same idea. With here they call it a controller, and here the call passes asynchronously through Kafka to the controllers, to the runners, and the results are being pushed to a database. This is useful, for example, if you break your batch jobs, your nightly jobs, into functions, and they can run asynchronously, and you can collect the results later. And OpenWhisk will manage it all for you. Last example, Oracle's FAS. As you can see, again, the same structure. Here they call it a LB, a load balancer, and it passes the call to these servers. You have the asynchronous option. You have some perks here and there, like cache or registry, but the idea is the same. But it doesn't matter which option you'll choose, you'll still have to pay for the servers, right? You still have to manage them. You might run out of capacity if you're lucky and your company is getting a lot of customers, more requests. You'll get stuck again. Either spend more money or move part of the workloads to the cloud and pay the cloud provider. Is there another option? Well, there is. You don't have to pay for that, right? Because you don't think about it this way. You already have tons of servers. For example, in AT&T, there are almost 250,000 employees. Each one has a laptop, very strong laptop, 32 gigabytes of memory, huge hard disk, and almost no one of these employees take it to the max all the time, right? Even if I work 10 hours, 14 hours of available strong machine. And even during work hours, I'm at meetings, I'm working on Word documents, I'm at lunch. Not to mention the managers who never utilize their machines. So you have a lot of power there. Even if we'll be very conservative and say that only 20% of the machines that are AT&T are available at a given time, which is very conservative, we're still talking about a cluster of 50,000 machines available for you to run workloads on them. And what's the most appropriate workload to run on a machine that someone else might use any minute? Serverless functions, right? They are short-lived. They don't consume much memory and CPU. And there are already frameworks to tell you how you can manage them. So basically, this is the idea, at least at the beginning. So I checked all of these frameworks and Kubernetes as well, and found out that they are not, although they can obviously run serverless functions, they are not very suitable for such a use case, because they assume that the server they're running on is theirs, dedicated to their workload. They don't check anything else, and they're not ready to be a second-class citizen on any machine. Right? So something had to change, so I built something on my own, based on the guidelines. That's why I showed you the common ground for all of them. And I built a small framework that demonstrates how this thing can work. So in every workstation, you have an agent running. Okay, if you install Docker, you probably have the Docker agent running. And I'm talking about Windows, right? Most of the workstation in the world are still Windows, if I'm not mistaken. So the agent is running there, and it's constantly monitoring the capacity of the machine. It samples the CPU, the memory, kind of like a Kubernetes kubelet. If you're familiar with Kubernetes structure, on the nodes, the kubelet is monitoring the health of the machine and reports to the Kubernetes controller, and it helps him decide where to run the workloads. It's the same concept here, right? I didn't invent a new concept, just a new usage. By the way, even running agents on personal computers and utilizing it when it's idle, it's not a new concept. If anyone remembers SETI, yeah, I see nodding. SETI was, I think it was Search for Extraterrestrial Intelligence or something like that. You had to run some agent on your machine, and when the machine was idle, this agent ran some calculation to find life in outer space or something like that for NASA. It was before Bitcoin, so I hope they didn't mine any cryptocurrency. But this is another use case for this. I wonder how much Bitcoin AT&T can mine with almost 250,000 servers. But I leave that as a side thought. Anyway, this agent reports the statistics to the gateway. So the gateway now holds the word image of servers. Again, like a Kubernetes controller, it knows which machines are available to it. Now, it can be smart as you'd like, right? It can then operate based on the latest statistics, right? Who was available now. And it can be smarter. It can even apply AI and more sophisticated statistics method to know that John is always leaving home early on Tuesday. Or Jenny takes a 2-hour lunch break every day. So I can use her machine safely, right? It can maximize the option to have a free machine or minimize the need to do a context switch and run the same workload elsewhere. So this is an option. And a developer, let's assume, for example, that we only want to run developer and test workloads on the workers' machines and not production because we're being safe. Developer writes the function code, pushes it to a Docker registry. In the middle, it obviously has to build the Docker image and updates the gateway that you have a new function, and the gateway assigns a URL to it, or at least knows about it. And when someone wants to invoke a serverless function, it calls the gateway applies its logic, or just chooses any available server, and tell them he wants to invoke a function. Function is basically a name of an image with some parameters, and the agent pulls the image from the registry, if it's not already there, and runs the Docker image, Docker container, and talks to the function. How does it talk to the function? He passes the parameters to the Docker container's standard input and expects to get the result from the standard output. This is a basic Docker communication option that you have. And everything was great. Let's see it. I hope the internet connection here is fast enough. I'll start my gateway. I built it all in Java. This is my native language. And I'll run 2 agents inside Dockers to simulate the fact that I don't have many machines here. So now I have a cluster of 2 runners with 1 gateway, and in the background you can see, I hope you can see it here as well, that they are reporting statistics all the time. So the gateway has some knowledge of what's going on. And to complete this picture, I've built a small UI that show me what's going on. Right, I have 2 runners listening on these ports, and I've never really invoked anything. So let's try and invoke something. This is how a function looks like. Simple function in Java. In the main, you see the common part. As you can see, all I'm doing here is constantly reading from standard input and writing to the standard output. And the function is the small method up there, not doing anything fancy, just reading the payload coming from the outside, converting it to a number, and adding 1,000. It can be anything, obviously, but it's good for demonstration purposes. I also created a small plugin for Eclipse to make the developer's life easier. So in order to send your function to production or to a cloud, or to be able to, so anyone will be able to consume it, you just have to do 1 click. That's it. When I click here, now I'm building it with Maven, building a Docker image and pushing it to a registry and updating my running gateway, as you can see in the console. And now if I go back to the UI, I can see that I have 1 function deployed. And I can even execute it from here. Now, since I have 2 runners, and none of them have the image of the function locally, because I've just deployed this image and push it to a registry, 2 things will happen. When I invoke this function for the first time, it's going to take a little bit longer. Don't worry, it's not going to take seconds, maybe 1 second. And after that, it's going to be much faster. And you'll be able to see that it divides the calls between the runners. Let's do a test here. I got a result back. From where? 1 of the runners, right? If I'll run this function again, two of them were invoked. Now I can run, it's going to be much faster. Sorry. Almost immediately, right? So there's no real penalty for the fact that we're sending it to inside a Docker container and running it there. One last thing, if we check out what's running on my machine, you can see the 2 runners there, and the name is of the functions, and they're not going to live forever, right? They started a few seconds ago. I let them run for about 45 seconds before I kill them. So if I do it, I'll give them a few more seconds, and they are gone, right? In order to free the memory and the CPU of the host they are leeching on. So although it's a framework for demoing purposes, you can easily take it or take any other open source serverless framework and do the necessary adjustment and run it on your organization machines, right? Why pay Amazon or Microsoft for the serverless execution. And there are many use cases, right? For example, running automation tests. We have thousands of automation tests, and they take a long time to run. So if we run them in a cloud, we're going to pay a lot. You can run them on the employees' machines. Headless, of course, they won't be bothered by it. Machine learning, right? To run machine learning workloads, you need to do a lot of calculations, a lot of learning, a lot of use cases. You have to train and iterate again, sometimes millions of times. Why not use the employee's machine? They're not doing anything with it anyway. So these are just a few use cases for you to play with. There's always the consideration whether to use it in actual in production, right? Can you trust it? And it's a complicated answer. I agree that it's more safe to run only dev and test workloads there, although you still save money because you pay for those workloads as well when you run them in the cloud. But if you make it into a true hybrid framework, you can even run production. I mean that you can start finding resources locally and use them. And if the gateway tells you that there's no available server, which will be rare, then you can send it to a cloud environment, either on Kubernetes or on a matching framework that runs in the cloud for these cases with scalability options, so you'll never run out of resources, but always utilize your local resources first. So this is the idea. But I'm not going to stop there, right? First of all, I would have been very happy to tell you that the story already had a happy ending, and now at AT&T we're using those 250,000 machines to run all the workloads of AT&T. This is not the case, sadly, because in a big corporate things are moving slow and they're a bit conservative. But they're moving, right? And that's the first bullet. That's my first goal, to actually make it happen in a larger scale in AT&T, because otherwise it's a waste of money. We have tons of machines just lying there waiting to be utilized. After I do that, or in parallel, if with your help maybe, we can do that everywhere, right? Every organization can do the same, and first fully utilize its own machines. It's even good for the environment if you care about these things. And why stop at the organization, right? Remember SETI. Let people at home sell their compute power to you. For example, in Israel, where we actually have a sun, everyone can install solar panels on their roofs and create electricity and sell it back to the electricity company, right? Actually, it only reduces the electricity bills usually, but it's happening. Why not in compute? If you have 3 machines in your home and your kids are playing with it some of the time, your wife is, writing her academic work there in the evenings, you have unutilized computing power. Sell it to other companies who need it, right? It should be cheaper than what the cloud providers are charging. And this is just the first phase. Take mobile phones, for example. I don't know what type of phone you have, but they usually have multiple cores, and when you charge them and not using them, they're doing nothing. And I don't remember who said this quote, but someone said that today's average smartphone has more computing power than NASA had when they sent the spaceship to the moon, and all we do is throw birds at one another. It It was at the time that Angry Birds was the popular game. So we have a small supercomputer in our pocket, which we can use. And why not cars? Hundreds of millions of cars traveling, they have strong computers. And many talk about electric vehicles, which are getting more and more common. And you charge them like you do with mobile phones, right? For large amount of time, I don't know, maybe every night, maybe all night, they are plugged in and doing nothing. And they have some strong computers in them. Someone once told me that an average car has the power of between 20 to 50 laptops. And that's especially true with autonomous car, right? Tesla and stuff, they have all the cameras and all the input they have to process. They have strong computing capabilities there. Why not use them? Actually, that's true for everything with a CPU. IoT devices, cameras that you have in your home. Anything with a CPU, you can utilize to some extent. And then we'll truly have a distributed cloud, right? The stuff that we have now, where few companies owns most of the computing power of the cloud, it's not a distributed cloud. They have regions everywhere in the world, but they own it. And the speaker before me said half true that no one knows what Web3 is. Okay? And I got to admit, I don't know what exactly Web3 is, but I know what it's talking about. It's talking about distribution, real distribution of the web, also with some blockchain to make everything secure, but it's talking about a distributed web. And this is exactly it. If everyone will be part of the distributed cloud, then we'll truly have a distributed web. And hopefully next year or so we'll be at the Distributed Serverless Architecture Conference. This is what I had to tell you, so thank you for listening. I know it's tough hours in the afternoon. And if you have any question, I'd be happy to answer now or later. You can ping me on LinkedIn or via email.